Okay, GPS. You've all got GPS in your pockets, probably on your smartphones. I remember GPS when it was. I mean, GPS has been around since about the 60s, I think, but it hasn't been available to us. It was developed by the American military to guide missiles to the locations and other stuff like that. And of course, they didn't let the rest of the world have all this because they thought, well, we'd all wreak havoc with it. And it was probably around about, probably about the late 1980s, maybe, I think, when they opened it up and they allowed GPS to be used by everyone in the world. But what they did was they scrambled it slightly. So everyone could use GPS, but it was only accurate to about 10 or 20 meters, so it was scrambled GPS. And they did that so we couldn't attack America and have a very accurate target. You know, that was the issue. They were just very concerned that it would be used for the wrong reasons, even though it's developed for military applications in the first place, really. And then, a bit later on, they decided to unscramble that, so now when we get GPS, we get the full accuracy GPS. So that is a free service which is available to everyone on the planet. Probably not too good if you're in Antarctica, because the satellites tend to be around the equator. So as long as you can sort of see south, that's fine. If you're out at the North Pole, it's a bit difficult to get the satellites, but you might still get a fix, I don't really know. Okay, so now we have GPS, which is pretty accurate, and you get different qualities of GPS receivers. The ones that you've got on the robots are about £50. Okay, so not too medium price, really, not too bad. Just want to remember, when they have got a GPS fix, which they won't likely do under this tin roof that we've got, when they do get a fix, the little LED will start to flash. So you might notice if you're taking the robots outside, the LED flashes, it means it's getting GPS. So that's just one way of seeing, has it got GPS. When you first switch them on, it can take up to about 10 minutes for it to get a GPS fix. And the longer you leave it switched on, the better the algorithm calculates your location. Just like with your smartphone, when you're trying to find out your location, you get a large blue area of where you are, and it thinks, well, I'm within about 100 meters of this. That's the radius of the circle. And the longer you keep your phone out, the smaller that circle becomes. That's because the algorithm is calculating and calculating where you are. And the more satellites that it sees, the more accurate the GPS, because it uses triangulation. It uses the time of flight to calculate your location. So it's quite amazing that it works at all, really. Now, it's not just America that have the GPS. GPS is the American system, but the Russians have made one as well. The Chinese have made one. Beidou. Beidou, that's it. Beidou is the Google, isn't it? Yeah. Yeah, get those confused. Chinese Google is Beidou. Beidou. No, I don't know. Anyway, you go to China, you can't use Google. You use Beidou, whatever. But they also have a GPS system which is called something very similar. And Europe have got one as well called Galileo. Okay. Okay, so let's look at GPS coordinates, and this is how we get it. Whichever GPS system we're using, it divides the world, and you probably all covered this in geography in the past, into degrees. Okay, so the Earth is a sphere, so it makes sense really to divide the Earth into latitude, which goes up from 0 degrees at the equator, up to 90 degrees at the North Pole. So we're fairly high up, so our latitude is around about 53 degrees. Okay, if we go further south, it goes a lower number until we get to the equator and it's 0. And we have longitude, which is measured from London, from Greenwich. Okay, and that's because probably Britain started this in the first place, you know, sent the ships to go and explore the world. Oh, where should we start? I know, let's make London 0. That's nice and easy, isn't it? So, it's quite lucky, really, that London on the Greenwich Mean Line, which you can go to, some of you might have been to it already, you go to London, you go to Greenwich, and there is actually a line in the ground, and you can hop from one side of it to the other. Yeah, from 0 and minus, plus, it's great fun. You do it for a good 12 seconds, and then you get bored. Okay, so that's 0. And as you go to the left, it will be a negative number. Okay, so at Harper Adams, we're to the left of London as you're driving, so we're at -2 degrees. But as you get to London, it would be 0 degrees. Okay, so we've got latitude and longitude, which you probably knew all about already. Now, what we've got is a command, well, a few commands actually, now to read the GPS. Now, the GPS receiver, it's hardwired. When you buy it, it will only give you your values once per second. So it only gives you a new GPS value once a second. So there's no point in trying to get it to read GPS faster than that. That's the circuitry inside it. Okay. Now, there's a few functions that we've written, and one of them is GPS avail, and in little brackets like that. That's actually a function that returns a true or false. True if it has got a GPS fix, or false if it doesn't. So it will be false indoors, and it will be true when it's outside and it's got a fix. So the code will only do this within the squiggly brackets if there is some GPS there. It's just obvious, isn't it, really? You don't want to be reading GPS and printing it out if it hasn't got a fix. So that's the one little command, GPS avail, for GPS available. Okay, so now we're going to use a couple of variables again in the loop. And remember, we've been using int for bearing because we're just using 0 to 359. Now, with latitude and longitude, it's going to be -2.706 blah blah blah. Okay, so that's the latitude and longitude. So they're fractions. So we have to call those double. So a double is a number with a decimal point. Okay, you can't really use int, otherwise the resolution won't be good enough. Because 1 degree of movement is probably about a mile of distance along the Earth. Okay, now this bit of code says if GPS is available, it puts the LT and LN are the two variables that I've declared. You could call them anything you like, really, within reason, but I'll just use LT for latitude and LN for longitude. And it just gets the lat and gets long. So get lat and get long will put those values into those variables. Okay? And then we all know what's happening here. Clear the LCD and print latitude and print longitude. Now there is something slightly different. We've got (6) here. You've not used that so far. What that will do was allow it to have 6 decimal places. If you don't put the (6), it only defaults to 2 decimal places for some odd reason. But you need to see really to 6 decimal places, otherwise you won't see yourself moving around. Okay, so it's quite good to have it down to 6 decimal places. So that's latitude and longitude. And that's all good fun because it works in degrees. And what you can do is go outside in a bit, get your latitude and longitude, come and tell somebody who's got internet. You could put it in your phone, or you could ask me, and we'll just put it into a search engine, and it will show you a map of where you are. So we can have a play with that when we get back in, once you've got latitude and longitude. So write down your latitude and longitude, and we'll put it into Google Maps and have a look. Okay, so that works directly. But when we're navigating with our robots, using all these degrees does get a bit confusing, because if you're at -2 degrees latitude and you want to navigate to 0 degrees latitude, how many meters is that? It's very difficult. You have to know what the radius of the Earth is. So we have another method called UTM. Now UTM is Universal Transverse Mercator, and what it does is again, it was developed by the American military, and it divides the world into blocks like this. And the blocks are about 60,000 metres roughly. You know, I'm kind of guessing there just to give you a bit of an idea. Sometimes the blocks are a bit squashed, sometimes they're a bit longer, but around Europe they're all about pretty much the same size. And you can see here there's a bit that goes around England. That's why I say it's England, because the block 30U goes around England, except for Peterborough and Scotland. Okay, so that's a different one. That's 30V. But we're not moving out of that block, so it doesn't matter. So northing and easting are values in metres, which go from just off Cornwall, just over there. So 0, 0 would be the left little point there. And as you move north, it counts metres, and as you move east, it counts the metres. So we're quite a high number at Harper Adams. So when you convert it to UTM, you will see the value in metres. Okay, quite a large number. So that will be another task, to look at your values in metres. Now this function has two inputs. It's got latitude and longitude in degrees, obviously, and it's got two outputs, northing and easting. So the two inputs are here on the left, and the two outputs are on the right. Now there's something you have to do which is a little bit odd in C language. If you want to return two values from a function, you have to put an ampersand. So the ampersand, the and symbol, will return these values. So there is a long-winded explanation to do with pointers and C programming, but I don't want to get into that right now. But the command is deg to UTM. You tell it the latitude and longitude, and as long as you put an ampersand to a variable and an ampersand to the other variable, and you've declared the variable up here, so you'll see that the top bit of code, and you will get this handed out to you, is declared here. Okay, it will return the values into there, and then you can print it out. UTM northing and UTM easting. Okay, and I've put a bit of a thing on the handout that you'll have which shows you what's going on.